x is equal with a times t minus sine t, and y is equal with a times 1 minus cosine t. The figure shows the circle of radius a rolling along a horizontal line, OX, and P is a point P traces out the cycloid, and angle T is in radians. It is the angle through which the circle has rolled, and C is the center of the radius. So first of all, let's prove this x is equal with a times sine t. So let me write here this one. So let me go first, let prove x is equal with a times t minus sine t. So to prove this one, first of all, we are looking those distances, OX. So OX here, or X, I would say just the X, is going to be equal with the distance OA minus distance AX. So now we are looking here in the figure. If we are looking in the figure, the distance AX is from the distance P to distance B, is the same distance. But if we are looking here in the triangle, and according to this triangle here, the sine t is equal to the opposite side over the hypotenuse. So let me write here a sine t is equal with the opposite side, which happen to be PB or AX, because we are looking for the AX, so there's a distance here to figure out in what relationship is with those parameters, here, and is equal to the AX divided by the hypotenuse A. AX divided by hypotenuse A. And if we are multiply everything here by A, whole equation, it turns out AX is going to be equal with the a times sine t. A times sine t. So we found this one here. But we want to find now the distance OA. The distance OA is equal with the distance, or with the part of the perimeter or arc length of the circle PA. So let me write here. So OA is equal with the arc length of PA, or we can write in this form, OA is equal to the arc length PA. So this arc length. But if you are looking here, PA here is equal with T time radius. So the arc length PA, so let me write here with a different color. PA, the arc length is equal with the A time angle T. And now OA is equal with the A time T. But now we are looking here at this equation, what we had here. X is going to be equal with the OA, so let me rewrite again, minus AX. But OA, we already know, is equal A times T. X is equal to the A times T minus AX, as we figure it out here, is equal, so here this is the AX, is A times sine T. Okay, A times sine T. But because here, as we see, this implies if we are factoring A, X is going to be equal to the A times T minus sine T. So we already proved the parametric equation for the X. We already proved for the X, so this one here, X is equal to A times T minus sine T. But now we want to prove this Y is equal to the A times 1 minus cosine T. And to prove that, we can prove this way. Y is equal, So this y here, this distance here from O to y, or y, is equal with the AC, whole this distance, minus BC or CB. So let me write here. Now we want to prove now. Let's prove a y. So let me write with a different color. So let's prove y is equal with a times 1 minus a cosine t. This one we want to prove. But to prove this one, first of all, as I said here, from the figure, we can find all y, or just the y, is equal with AC minus BC. So this whole this distance here, taking this distance here, is equal with y. So y is equal with AC minus BC. But now AC, if we are looking here for AC, what is the AC? AC is equal with A. So with the radius of the circle is A. So AC is equal with A. So this was very easy. So just let me go here. We already see AC is equal with A. So we already found this from the figure. But we want to see what is the BC. And BC we are going to look from the small triangle here. So BC is from the small triangle, BC here. But this angle here, cosine t is equal with adjacent divided the hypotenuse. So the cosine t is equal with BC divided by A. So let me write BC is equal with BC. I'm sorry, let me erase this one here. We already know the cosine t is equal with BC divided by the hypotenuse A. If we multiply again this by A, this implies, so BC is equal with A times cosine t. And finally, if we are substituting in the y, AC what is A and BC A cosine t, we can find y is going to be here. Instead of the AC, we have A, and here is a minus BC. BC happen to be A times cosine t. A times cosine t. And now if we are taking here, if we are factoring A in the front, A is going to be 1 minus cosine t. So we already proved the other parametric equation. So we are looking here up. So y is equal with A times 1 minus cosine t. And we already have here A is equal with y is equal with A times 1 minus cosine t.